So in this video here, we want to look at basically all the inputs and outputs that are available on the sorting station to us, okay? So this is excluding any additional inputs or outputs that may be potentially wired in on those ports down the front, okay? Now, in a previous video, we've talked about the control panel, so we'll not discuss any further on the inputs and outputs available for that. Okay, now they're the exact same for all the MPS stations, and they're all wired in the same way for us, okay? So yes, they are available to us. But what we want to do is we want to look at the top part. Okay, obviously each MPS station has a different function, different kind of sensors and inputs and outputs available on the top, but we're just going to discuss in particular or specifically to the sorting station, okay? Now, at the front, all we have here is we have the syslink cable that is connected across from the PLC that we see here, and that just basically takes all the inputs and outputs. You can see them all wired in there, takes them nicely, distributes power, 24 volts as well in here, and then what we do is we have a breakout board that they're breaking out basically the inputs and the outputs. So we can see these are actually all the input signals up the front, and then we've got our outputs down this side here. Okay, so that's all really this is doing. We don't need to get too worried about it. We can also see the visual indicators of the inputs and outputs being triggered, but we can also trace them back to the LEDs that are on the module cards that we've seen before. Okay, so we'll not worry too much about that for the moment. And then in another video, we've talked about manually overriding the pneumatic valves here that trigger some of the outputs, some of the cylinders, okay? So usually you can get some pins to or a pen that will override those manually, okay? Without the need for electrical power. Now we'll discuss a little bit about that, but there is another video on it. Okay, so let's get into the inputs, right? Now, first of all, there is 8 inputs available on the top here. So we'll quickly just identify those. We've got input, an input, another input. So there's 3. We have this input here, that's 4. And then what we have is we have 2 inputs on each cylinder. So one on this side and one on this side. You can see the LED there, and then the same there. So 2, 4, and there's our 5th, 6th, 7th, 8th. So they are the 8 inputs we have available to us on the top of our system. Okay, so it's important to know how many we have, where they are exactly wired in to the PLC, and then what function they carry out. Okay, for the most part, all our inputs are wired normally opened. For this station anyway, it is very important to note if you do have a normally closed wired input, because that will impact your coding. So let's move our discussion in towards the front here. And what we've got is we've got 2 very similar sensors, okay? They're diffuse sensors, but they're set to trigger at slightly different limits, okay? This one here, we usually call it a part present sensor because it detects if a part or a product is present at the start of our conveyor, okay? And we use that usually to trigger the operation, okay? So what this will do, it will detect anything. It will detect red, metal, black, or even my finger, okay? It will detect anything at the start here. So that's what it's set up, and the sensor is set up to do. So it's a diffuse sensor, sends out a beam of red light, you can see that, and based on the amount of reflection it gets back, it will trigger the sensor. So kind of like a proximity sensor, just detecting that something is near it. So that's what that does. We usually use that to indicate that something is here at the start of the conveyor. But remember, that will detect anything. My finger, it will detect red, metal, or black. Now, usually what happens is the motor will move forward, and then we have it being held here in place, and we have our 2 other inputs here. So what these 2 inputs do is, one, like we said, is a diffuse sensor. We call it commonly a color sensor because what it will do, it's set up slightly different to this sensor, although they look very similar. it will detect the difference between red and metal. Okay, now if I just swing around here, we can see the reflection. Again, the beam of light is being reflected out, or being sent out, and then it's being reflected back onto the sensor. Okay, so what we have is we have bright colors will reflect more light than dark colors. They will absorb the light. Okay, so that can tell us the difference between light and dark colors. It can't tell us the difference between shades. Okay, so if you had black here and navy, it couldn't detect the difference between those. So we commonly call this our color sensor. It is a diffuse sensor, and it will just detect the difference between the light and the dark objects. Now note, the metal and the red are both light objects. So that sensor will give out a signal, it will turn on for both of these. It won't turn on for the black. So then how do we further distinguish what product we have? We need the metal sensor here, which is our metal sensor, our inductive sensor. And you can see the light is on when it's a metal, and then you'll see if I put the red in, it's off. Okay, so for the plastic, it doesn't detect. So there are 3 key sensors, and we detect, okay, a part is on the conveyor, we detect is it light or dark, and then is it metal or plastic. Okay, and those sensors really give us the indication to help distinguish which pathway the products need to go down. Okay, so hopefully you understand those 3 sensors there. Then we have a slightly different optical sensor. Okay, it sends a beam of light across over to the reflective surface, and then it comes back onto the receiver, which is again on the same sensor here. So there's a beam of light going across, and once we interrupt that beam or break that beam, the sensor will give a signal to the PLC. So it will turn on once we break the beam. Okay, so you could see these commonly wired the other way, but this one, once we break the beam, it will give a signal. So that lets us know that something has passed down through one of these 3 chutes. We don't know which one, because it's sending the beam across all of them. We don't know if it's just a finger or if it's the product. Okay, so it just, again, kind of like this sensor here, it will sense anything that comes through its pathway. So that's 4 sensors. The other 4 sensors are quite straightforward. They just detect, and we commonly have this for all our cylinders. We've just got a cylinder here, okay, a pneumatic cylinder, that will extend out. So you'll see when this pushes up, it will push the arm across, and then it will retract. And what we just need to know when we have extended and when we have retracted. It's important to know the position of our cylinders. So that's what these sensors are doing. They're a magnetic proximity sensor that basically, when it's retracted, we can see that that's on. If I put it halfway out, we can see that sensor is off. And if I put it the full way out, it's just on the other side here, we can see that sensor is now on. And it's the same on this side for this for this cylinder, and again there for that sensor. Okay, so those 4 inputs are all the same. They basically tell us the position of our cylinders, whether they are extended or retracted. The other thing to note is we have a cylinder here, the little stopper arm, but we've no position sensing on this. Okay, so that's important to note. So that is all the inputs we have available on the top half. Okay, remember that's not including what we have on the control panel. Okay, and it's not including any other additional inputs or outputs you may add to the system. Now for the outputs, we don't have too many, so quite quickly, what we have is we have our conveyor, so it's just being powered by a DC motor, and all we have the ability to do with this conveyor is to turn it on and to turn it off. Okay, we can't reverse the polarity, make it reverse or anything like that. we can, or speed up or slow down, we can just turn it on and turn it off. So a simple DC motor that's just going in the forward direction, so taking the products forward. So once the PLC turns this on, the conveyor moves forward, and then once we turn it off, the conveyor will turn off, okay? Then we have control. The other three outputs are our cylinders, okay? Now the important thing to note with these cylinders is they're all spring return cylinders, okay? So if I just turn on the air here, that is important because that affects our code. So you may have latching and things like that to come into it. So if I just manually override these, and I'll try and get this in the best shot possible. So you can see as I push manual override, so that's me turning on the output. So imagine the PLC is doing that electrically. And then when you turn off the output, it springs back. And that is the same for all our cylinders, okay? So they're all spring return cylinders, so they only have one output to control the movement. So you turn on the output, it will extend these cylinders, and you've got to keep that output on, and then when you turn off the output, it will spring back automatically. So that is different to some cylinders, like a double acting cylinder, well, just with no spring. This is a spring return valve actually. Just if they don't have a spring return, you would have an output to send it forward and then a different output to send it back. But here we just have one output, turn it on, it sends it forward, and then when we turn it off, it springs back automatically, okay? So hopefully that's clear, and that you've sort of seen that. Turn the output on, and then it springs back automatically, and you can just see it down here. I'm just overriding the valve, so it's on, and then if I take it off, it springs back. And then just finally on this, the exact same thing. So again, spring return, small little cylinder, very small, but note this starts extended and then it retracts, okay? So just slightly different to these. If we turn on the output, that cylinder will retract, and then when we turn off the output, it will spring back out to the front. So they are all the inputs and outputs that we have available just on the top half of the system. Again, just remember we have the control panel down here at the front. That's connected to our PLC. Like we discussed before, we have 2 input cards and 2 output cards. Each of them can hold 8 inputs. So that means, 8 devices. So that means we can have a total of 16 inputs and 16 outputs available on the complete setup. Like we said in another video, we don't utilize all those ports. There is some free that we could add additional inputs and outputs to the system if we wanted, like maybe some of these LEDs as well. So hopefully that's clear. It gives you a good idea of what's available on the system, and then it's a case of coding it, utilizing all those inputs and outputs that's available to get the system working.